Today we are starting a unit called All Gone, and it is everything you ever want to know about polygons, including special quadrilaterals and all the details about them, along with finding the area of all polygon figures. And so kind of a lot involved. We're going to start with parallelograms today. Looking at parallelograms in general, a parallelogram is a quadrilateral that specifically has two pairs of opposite sides that are parallel. That's what the definition of a parallelogram is. And parallelograms have some other special properties about them. If you were ever wanting to use these in a proof, which we will be wanting to do that, you would say if parallelogram, then, and then you would write one of these statements. So the options are, if you have a parallelogram, then you know that the opposite sides are parallel and they're also congruent. So you could put either of those, or you could put both at the same time. If they're both going to be helpful for you, you would go ahead and write both of those things. Opposite angles in a parallelogram are congruent. Consecutive angles are supplementary. Consecutive angles in this parallelogram would be like this angle here, angle ADC, that up there at the top, and this angle down here at the bottom, angle DAB. And those would be supplementary to each other because of the fact that if it's a parallelogram, then line DC is parallel to AB. And if those are parallel lines, then that has transversal DA, making those same side interior angles, and therefore supplementary. Another thing that's true about parallelograms is that the diagonals will bisect each other. So if you know that you have a parallelogram, all of these things are true. Let's use some of those properties. These are some very basic examples. You will see some examples that are a little bit more involved. Some may involve algebra. Some you might just be finding an angle like these. Some of them could be as difficult as having to do like a system of equations. We want to find angle B in this first image, and we're given angle A down here at the bottom. Well, how angle A and angle B are related, these are consecutive angles here, and so we're going to be adding them to 180. So if you do 180 minus that 64-degree angle, you are going to be left with 116 degrees, and that will be the measure of angle B. On question 2, they gave us angle K, and they wanted us to find angle M. Well, angle K and M are opposite angles, and therefore they are congruent to each other, so angle M will also be 96. These are basic demonstrations of two of the properties of parallelograms, one being that your opposite angles are congruent, that's question 2, and question 1 demonstrating when your consecutive angles are supplementary. Like I said before, they can make these harder by having more algebra expressions involved in them, even possibly including having to work out like a system of equations. On number 3 here, we have the sides of the parallelogram labeled. And if we have a parallelogram, then our opposite sides are congruent to each other. So this side will be congruent to this one, and this one will be congruent to this one. So we have two equations that we can write. X plus 2 equals to 4, so x equals 2. Pretty basic. Y minus 5 equals 12, so y equals 17. On question number 4, we have a set of sides labeled here and here. Those will be equal to each other, can be used to solve for x. And in our solving here, I'm going to subtract 4 from each side and divide by 3. And to solve for y, looking at what they're labeling for y, they're labeling angles, and these angles are opposite from each other. And so since our parallelograms have opposite angles equal to each other, we can set these equal. So we're going to solve by adding 60, which is going to give us y equals 116. So just some basic practicing, knowing that if we have a parallelogram, our opposite sides are equal and our opposite angles are equal as well. On number 5, kind of the same thing going on here. We've got some sides labeled. Opposite sides are equal, so 8g minus 3 equals 25. We can solve this by starting by adding the 3 here. So 8g is 28 and dividing by 8. And if it doesn't divide nicely, remember to leave your answer in fraction form. It's going to be 7/2 when you reduce that. So that is g. Looking at the variable f here, it's in some angles. It's in this angle up here and this one here. These are not opposite angles. Since they're not opposite angles, you're not going to set them equal to each other. These are consecutive angles, and that means that they're going to add to 180. So we're going to add these two angles together, equal to 180 because they're supplementary to each other. Simplifying on the left side, combining my like terms. Subtracting the 102 gives me 78 for F. Looking at number 6, what they're labeling on number 6 is they are labeling pieces of the diagonals. And if you have a parallelogram, then your diagonals are bisecting each other. What that means is that the pieces of the diagonals are going to be equal. So where this m plus 8 is will be equal to the 3m, and the 9 is equal to the 2n minus 1. So m plus 8, 3m, and this will give me 8 equals 2m and m equals to 4. And then to solve for the n there, 9 equals 2n minus 1. We're going to add 1, divide by 2, 5 is n. So pretty easy if you know which rules you're trying to apply. Number 7, same kind of thing. You might want to pause the video and try this one out yourself. And then push play again and see if we get agreeing answers here. All right, hopefully you set these equal to each other because these are pieces of the diagonal, such as 6k equals k plus 10. Subtracting k would give me 5k equals to 10, and k would equal to 2. To solve for j, 3j equals 5j minus 9. I'm going to subtract the 5j. It will give me minus 2j equals negative 9. Dividing by negative 2, j equals positive 9/2. Could also write that as 4.5. Better to have a mixed number than to have a decimal. On this one, we have a lot of angles being requested, and we are told that ABCD is a parallelogram. Now, keep in mind that being a parallelogram also gives you those parallel line things happening with the alternate interior angles and that sort of thing. We've also got some vertical angles in this picture, and we have triangles, and gotta keep in mind about how the angles of a triangle add to 180. So tons of things we can do here. I'm going to start by labeling line AB and DC and kind of focusing on how they're parallel to each other. We can pick one transversal to use. We actually have two, and we'll be using both of them. But if I'm focusing on this one here, kind of makes a Z shape. That makes those alternate interior angles, and alternate interior angles are congruent, so this could be 23 down here on the bottom. We can also do some using the left side and the right side, and using that 80 that was labeled there, have some alternate interior angles with the 80. That will bring the 80 over here. So that gives us two angles to add to our picture. I'm going to use now the triangle at the bottom. I noticed that I have 2 out of 3 angles in that triangle at the bottom, and they should add to 180 degrees. So I'm able to use 23 plus 117 subtracted from 180 to find 40 degrees to be what is remaining there at angle C. Let's see what else we can do. We can use linear pairs in the middle here of the picture. We have a linear pair. 180 minus 117 is 63. We can use vertical angles and vertical angles. Just adding some angle values here. That allows us to have more triangles where we have triangle sum of adding to 180 again, or you can use some more alternate interior angles if you like. The angle here that is labeled with a 40 is alternate interior with this one up here. That allows me to bring that 40 up there. And I'm going to use one of these triangles to get my remaining angles. So I'm going to use this triangle here. I'm highlighting in blue. And the triangle sum is 180. So adding 80 and 63 and subtracting from 180 leaves 37. And then alternate interior, we can drop that 37 over there as well. Now it's just a matter of finding the angles that they're requesting so that we can answer the questions. So AEB, remember that starts at A, E is the vertex, and then goes to B. Think of like connect the dots. That outlines the angle that is 117 there in the middle. AED is outlining A to E to D, is outlining this 63 there in the middle. BAD, start at B, go to A, go to D. That's going to be adding the 80 and the 40 together in the corner there, and that's going to be 120 degrees. ADC, A to D to C, that's these two at the bottom corner added together. 37 and 23 add up to 60 degrees. BAE is going from B to A to E. That's this upper one here where it says 40. So that is 40 degrees. ECB. Start at E, go to C, go to B. That outlines that 80-degree angle there. DCE. Start at D, go to C, go to E. That outlines that 40-degree angle there in the bottom corner. DCB. D to C to B is these bottom two together. So that is 120 degrees. So with these, you have to start with what you're given. You have to use your parallel lines, use your rules about, alternate interior angles, vertical angles, linear pairs, triangle sum theorem, just using everything you can to get any of the angles that you're looking for. Right here, it says the diagonals of parallelogram VWXY intersect at point Z. Find the coordinates of Z. Well, we know that if we have a parallelogram, then the diagonals bisect each other. This means that where they are intersecting is going to be the midpoint of both of the diagonals. So what we can do is choose one of the diagonals and use the midpoint formula. And once we calculate the midpoint of that diagonal, that should be the coordinate of point Z. I'm choosing this one here because I like that point V is at 0, 0. And I can use the grid that counted by ones, and I can label point X. Looks like an X value of 7 and a Y value of 6. So take care in identifying that point because, of course, our answer is totally reliant on us doing that correctly. So I have the 2.00 and the 0.76, and I am using the midpoint formula. So if they bisect each other, then Z is the midpoint. The midpoint formula is to add your X's and divide by 2. That gives you your X coordinate. And add your Y's and divide by 2 to get your Y coordinate. It's just the average X and the average Y. So adding together, dividing by 2. The X value, we're going to leave as 7 over 2. The Y value, 6 divided by 2, would be 3. This is the coordinate for point Z. I'm going to show the rest of the notes in a second video. This video is basically the properties of parallelograms. If you know you have a parallelogram, things that you can do to solve your problems. The next video will be if we are trying to prove that we have a parallelogram and the things that we would need to say to prove that it's a parallelogram.